Okay, let's unpack this. If you, like most of our listeners, have dabbled in the current wave of artificial intelligence,
Hmm.
you've written an email using a generative tool, maybe you've used a large language model like GPT for some brainstorming,
Right.
you've mastered the AI of today, but we are here today because, well, the horizon is already changing.
It really is.
Our deep dive mission is to move past this familiar world of large language models, or LLMs, and explore what's next. Agentic intelligence.
Yes.
This is that moment where AI stops just responding to your prompts and starts, acting autonomously on complex, multi-step goals.
It's a truly fundamental shift. I mean, what we're talking about here is intelligence that really transcends the capabilities of traditional LLMs.
Right.
It's no longer just about generating fluent language. It's
Right.
about autonomous decision-making,
Hmm.
goal-oriented learning, and even multi-agent collaboration.
So for you, the listener, this means the difference between using an AI to write, say, a marketing draft
Yeah.
and using an AI system to analyze market trends, design the ad copy, procure the ad space, monitor the performance, and then adjust the budget, all by itself.
Hmm.
We're moving from digital assistants to digital executives.
Exactly. The critical concept to grasp here is that an LLM is reactive. It waits for your input. An AI agent is proactive.
Proactive.
You give it a high-level mission, and it generates a plan, executes the steps, evaluates its own progress, and self-corrects until the goal is achieved. That functional autonomy,
Mhm.
that's the next great leap.
So if we're going to navigate this new landscape, we need some clear definitions. I mean, the terms generative AI, LLM, agentic AI, they can feel interchangeable sometimes, but they describe very distinct functional roles.
Yeah, they do.
Let's map out that relationship first.
Let's set up the functional comparison.
Yeah.
The broadest umbrella here is generative AI.
Okay.
This is defined by its ability to create content. Text, images, codes, synthetic data. It's the creation engine. So think of models like GPT, DLE, or Midjourney.
Right. The stuff we see everywhere.
Yeah. Exactly. Its uses are wide, covering everything from simple research assistants to, complex media creation.
And LLMs are a key subset of that massive generative category. They specialize in language.
Precisely. LLMs are powerful text processing and generation engines. They're the foundation of modern conversational AI. However, if you compare them to agents, you see where they stop.
Right.
They are fantastic at predicting the next word, but they lack the core architecture for continuous action and iterative self-correction. They can solve step one of a problem brilliantly.
But they can't handle steps 2, 3, and 4 without you constantly checking in and pushing them forward.
Exactly. You have to keep prompting.
So if generative AI is the artist and LLMs are the expert communicator, then agentic AI is the project manager, using those tools to get a specific outcome.
That's a great analogy. AI agents, or agentic AI, are defined by their goal orientation. They aren't just generating content, they're managing tasks.
Mhm.
They use memory and context retention to build up experience over time, which lets them adapt their behavior, meticulously plan out a sequence of actions, and even work alongside other agents. When you look for the differentiator, always look for the word autonomy.
That autonomy is the key. So let's zoom in on what enables that independence. What are the key sophisticated features that make agentic AI fundamentally different from the GPT we're all using right now?
Here's where it gets really interesting, because the architecture is it's designed around dynamic action.
First on the list has to be autonomous decision-making. We're not just talking about choosing the most probable word in a sequence. These agents are capable of making genuinely independent choices.
Yes, based on learned context, the resources available, and the goal state.
Right.
And think about the practical application of that. If you task an agent with booking an optimal flight itinerary, say, factoring in price, connection time, luggage restrictions.
A real-world messy problem.
Exactly.
Yeah.
And the first website it tries crashes, a traditional LLM would likely stop and say, I encountered an error.
And just give up.
But the agent instantly pivots. It reevaluates the failure, checks for other booking portals, and moves to the next best option without any human instruction. That's the power of true autonomous decision-making in action.
And that pivot you mentioned leads directly to the next critical feature, self-correcting reasoning. The agent doesn't just fail and restart, it learns from that failure.
Absolutely. This is perhaps the most significant evolutionary step. The model continuously evaluates the feedback it receives, positive or negative, and it adjusts its own strategy.
So if path A failed?
The agent internally models why it failed, updates its strategy, and tries path B, thereby ensuring continuous improvement without you having to intervene and retrain it. It's dynamically improving its own capabilities with every single task.
And for continuous operation, whether it's a few minutes or a few months, the system needs memory and context retention. It needs to know what happened last Tuesday.
Crucial for complex workflows. It's not just a short-term memory buffer like the context window in an LLM. It's a comprehensive long-term retention system.
So it remembers everything.
It retains information from previous interactions, entire tasks, learned strategies. This provides the continuity you need for these complex, personalized experiences, allowing it to take on missions that might span days or even weeks.
And since big problems often require teamwork, we see the rise of this collective intelligence through multi-agent collaboration. The source material really emphasizes that these AI agents can work together.
Yeah, sharing information, delegating subtasks, and coordinating actions to enhance their collective efficiency.
So what would that look like?
Well, imagine simulating a massive, complex supply chain. One agent is managing procurement, another is handling logistics scheduling, and a third is monitoring real-time financial risk.
Wow.
They communicate, they coordinate, and they solve a problem much larger than any single agent could tackle alone. It's the formation of an autonomous digital task force.
But a brain is useless without hands, right? So what connects that powerful reasoning engine to the external world? That's where tool and API integration comes in.
Exactly. This bridges the gap. Agentic AI is designed to use tools. It interacts with the real world by integrating with existing applications and systems, CRMs, trading platforms, data systems, even controlling robotics.
So if it needs to update a spreadsheet?
It executes the command via the right API. It turns digital reasoning into real-world action.
That's a powerful list of capabilities, but I thought our listeners would appreciate a look under the hood. How does the agent's internal architecture support all this planning and self-correction?
Yeah.
What are the functional layers that allow it to operate as an independent decision-making entity? Let's use an analogy to map this out.
That's a good idea because just listing the components can sound like you're reading a systems diagram. Let's compare the AI agent to a specialized organism or a highly organized human team on a mission.
Perfect. So where does the mission start?
It starts with the senses, or we call the perception layer. This is the agent's input understanding.
So how it sees the world.
Exactly. It's how it takes in your command, reads environmental feedback, and gauges the context of the situation, be that a data stream, a user query, or the successful or failed output of a prior step. This layer dictates how the agent adapts its behavior.
So it perceives the input, and then that information moves to the brain, the reasoning and planning systems.
Yes, and this is the heavy lifting. The agent doesn't just react. It reasons through the situation, it models potential outcomes, and then plans a detailed, multi-step sequence of actions to achieve its goal efficiently. It's not just generating the next sentence, it's generating the next 20 actions.
And if those actions require recalling complex information from, say, months ago, that's where the advanced memory management system comes in to support that reasoning.
Correct. The memory layer is crucial for anything beyond a simple one-off query. It retains and recalls both short-term working context and long-term knowledge gathered from all past actions and interactions.
It builds institutional knowledge within the agent itself.
It does. It avoids making the same mistakes or asking for the same information over and over.
So, the agent sees the world through perception, thinks with reasoning, remembers with memory. What executes the plan?
That's the hands the action executors. Once the plan is finalized, this is the capability to execute real-world interactions. This means controlling systems, writing code, interacting with databases, sending emails, scheduling meetings. It's the part that uses the APIs we discussed earlier.
And after the action is executed, the agent needs to check its work. That's the feedback evaluation and multi-step task handling part, right? It closes the loop.
Precisely. This is like the nervous system.
Mm-hmm.
The agent doesn't wait for you to tell it if it's succeeded. It continuously evaluates the feedback from its actions and adjusts its approach in real time. If the code it wrote failed to compile, it knows immediately, and the reasoning system goes back to the drawing board.
It's an iterative, ongoing process.
Fundamental to self-correction.
And finally, we have human AI teaming and learning reinforcement. So even though they're autonomous, they still rely on us.
They do, and this emphasizes that this isn't about replacement, but collaboration. Agents can learn directly from human feedback and direction. When they get stuck, or if a human supervisor overrules a decision, that feedback is incorporated into the agent's memory and reasoning systems
Improving its ability to collaborate in the future.
for superior long-term outcomes, yeah.
So if agentic AI is this ultimate goal-oriented architecture and it's using LLMs as a foundational layer, we need to clarify the LLM's role. Are they just dumb components being commanded by a smart agent?
That's a great question, and absolutely not. Agentic AI relies on LLMs heavily, almost as a high-powered operating system for communication and interpretation.
I see.
LLMs provide that foundational fluency and intelligence that the agent uses to interact with the world and understand human inputs.
So they are essentially the agent's voice, its translator, and its initial data processor.
Exactly.
We see them used crucially for natural language. Understanding, taking our complex, messy, ambiguous human instructions and turning them into structured data the reasoning system can process.
Exactly. And they're essential for something called instruction tuning. This is a technical term, but it's vital to the agent's reliability.
Okay.
It's the process of training the LLM specifically to follow complex, multi-step directions from a human user accurately. This ensures the agent correctly translates the high-level goal into executable steps.
The LLM capabilities are also critical for internal self-improvement through model evaluation metrics.
Yes, using the LLM's own understanding of language and logic to evaluate the success or failure of its actions and refine performance. It's AI judging AI.
And we can't overlook context window expansion. The LLM's capacity to consider more context at once is fundamental.
Absolutely. The wider the context window, the more information the agent can hold in its immediate view, the more nuanced and informed its autonomous decisions will be.
So the agent is the doer, the planner, the self-corrector, and the LLM provides the sophisticated communication, interpretation, and the cognitive foundation for it all.
Precisely. And to enhance both of these, there's another crucial support technique that provides accuracy and real-time grounding: retrieval augmented generation, or RAG.
RAG sounds technical, but if we connect this to the bigger picture, it's about making sure the AI isn't just, hallucinating or relying on outdated training data.
It is entirely about veracity and specificity. RAG works by retrieving highly relevant, up-to-date information from vast external or even proprietary databases before generating an output.
Okay, so it looks things up first.
It pulls in the document or the data point and then uses that specific verified context to formulate its answer or plan its next action.
So instead of trying to answer what were last quarter's sales based on its old training data,
Right.
the RAG system connects, pulls the live Q4 2025 sales figures from the company database, and then the LLM formulates the report.
That's exactly right. This capability boosts performance significantly in dynamic environments. For an agent, this is indispensable. For example, in real-time conversational AI, RAG helps with real-time answers and enhances customer support quality.
And for the content generation role that LLMs play for the agent, a RAG would ensure the creation of, say, legally sound or contextually rich documents.
Exactly. If the agent needs to draft a contract, our RAG pulls the company's specific legal templates and ensures compliance.
Oh, I see.
And most importantly, for agentic systems, it provides critical decision support. By pulling in real-time data from financial feeds, inventory systems, logistic trackers, RAG helps AI agents make much better, data-grounded decisions as they plan their multi-step actions. The plan isn't based on general knowledge. It's based on the most current truth available.
So if we pull back and synthesize all this, we started with these familiar reactive systems, the LLMs, and we've charted a course to this new paradigm, proactive autonomous agents.
Agentic AI represents a fundamental evolution. We've moved beyond simple, passive data processing and content generation towards systems that can genuinely perceive, plan, act, learn, and collaborate.
Right.
They're capable of making independent, complex decisions and improving their own processes through continuous feedback.
The power combination is truly transformative, and this is what you need to remember. You have autonomous, goal-oriented action, that's the agent, powered by the fluent communication and interpretation of generative AI, that's the LLM, and grounded in accuracy and real-time context, that's RAG. This synergy just opens up massive possibilities for systems that are not just smart, but truly productive and efficient.
And this raises an important question for you to ponder as you watch this space evolve. The path is now paved for intelligent agents that can handle increasingly complex, multi-step tasks across every industry, from automated financial analysis and personalized drug discovery to complex manufacturing logistics. The real question is not if agents will arrive, but where the ability to plan, self-correct, and manage multi-step processes provides the greatest immediate competitive advantage. Which sector, with its high stakes and complex workflows, will be the first to be utterly transformed as agents begin managing these entire goal-oriented missions autonomously? That's where the massive capital and agent deployment will happen first.